Math question here for you. It says in the figure below, triangle OAB has an area of 72 and triangle ODC has an area of 288. Find X and Y.
All right, that looks like geometry because there's a picture drawn.
You can have it.
I'm going to take this one. And glancing at this at first, I'm going to make a couple of assumptions about kind of what you know. Otherwise, this problem could take the rest of the show, kind of explain everything. What you're going to see in here is some right triangles. You're going to see some similar triangles. And then you're going to see some other algebraic equations that we have to assume and make on the way. So again, I'm not going to go into what similar triangles are. If you're getting a problem like this, it's fairly challenging. I'm going to go ahead and assume that you are comfortable with similar triangles. And I will talk about how we know they're similar, but again, not going to go into the details of it. So you kind of notice that there's a circle drawn here. When I'm looking at this and I try to kind of work out the steps in my head, I don't really think that circle is that important, but maybe I'll be surprised as we go. So right here, it says in the figure below, triangle OAB has an area of 72, and ODC has an area of 288. So let's just take a look at what they're giving us first. We have OAB, which is this little guy right here, and this has an area, and I'm going to write this off to the side. And again, I like to do this little subscript here, area of OAB equals 72. And then we have this bigger triangle here, ODC, which still starts with the same thing. And this is really important that they kind of share this vertex. ODC, which is here. Something like this that has an area of, what do we say, 288. Someone say area of ODC equals 288. And again, I have to point this out a lot. The OAB and the ODC, remember that subscript is just because we're talking about area for both figures, and we need a way to differentiate between, are we talking about OAB or are we talking about ODC? Okay, so here's one thing that you might notice. We're talking about area. So my first thought is area equals 1/2 the base times the height. And if you think about area, or if you think about the height of a triangle, we always have to kind of go straight down. Let me just sketch a quick example. If you had a triangle like this that I sketched, right, our area is going to it's not going to be this kind of slanted length right here. Oh. It's not going to be this slanted length, right, because nobody measures at an angle like that. It's going to be straight down. Think about from the very top, straight down, and it's got to be perpendicular. So when you look at this, you probably notice two things. One, neither of these triangles are completed. And two, you don't see anything in there that indicates a height. So I'm going to erase some of this because there is something that we are allowed to do. And in geometry, this always seems a little I guess kind of off-putting at first, because in geometry, your teacher hopefully emphasizes over and over again, you cannot make assumptions, which makes it feel weird to kind of draw something and say, this is what I drew. But we can do that as long as we make that statement. And I'll give you an example of what I mean here. If I'm looking at OAB, so I'm going to work with that first. Triangle OAB has an area that's 1/2 the base times the height. So we know the base length is right here, that is 18. The question is, what is the height, and how are we going to use that? And we'll kind of get to how we're going to use it in a bit. So the height here, we can actually draw it ourselves, and we can make this a right angle. Right? We are allowed to do that because what we're saying is what I drew is perpendicular. It does represent the height, and I labeled it, and I'm using it that way. So we are allowed to do that. And so we know OAB has an area of 72. 72 equals 1/2. We know the base is 18 because that was, that was given to us. But we don't know the height. And right now, if you're watching, you might be thinking, what are we going to use the height for? And I will get to that. Trust me, that's important information. So we go and we solve this from here, and we say 72 equals 1/2 of 18, which is 9h, and then h equals 8. So again, I just want to point out one more time, I am kind of rushing through some of this stuff that we usually spend more time on the steps for solving. but I'm assuming that you're comfortable with that. And so if you're not, feel free to give us a call, and I'm happy to kind of walk through any of that a little bit more in detail. The next thing we were looking at is the area of ODC. So I'll do that in green. It's still going to be half the base times the height. And now we know the area is 288. Now, the problem with this is we don't know the base, and we don't know the height. So again, I'm kind of working through my process here of how I would do this. And part of that is realizing as you start solving, as you're trying to work through these geometry problems, is realizing what information that you don't have and then thinking about how you can figure that out. So what I'm going to do is complete this triangle like I already had and erased for some reason. And I'm going to say I don't know the base, right? I know that I've got a base here. If you think about like this big triangle, big green triangle, I've got a base here, and I know part of it's 18, and I know the other part is y, so if that were a number, I would add it. If it's a letter, I can still add it, and that's what I know. But again, we don't know how to figure that out. Okay, we do know that the height of this little triangle is 8. Now, here's where we get to the similar triangles, and again, that's why I say it's kind of, you got to go back and forth a lot. This happens a lot in geometry. So what you should remember, let me erase this. What you should remember is similar triangles. You know two triangles are similar if you have two angles that are the same. All right, so if I have a triangle like this, and then I have a bigger one, and it looks similar, if any two of the angles are exactly the same measurement, like this, and maybe like these two, then I know that these triangles are similar, and what that should tell you is that they have similar proportions to each other. So when we look at this, it's not automatically clear that these are similar, but you do have two angles that are the same. So if you think about this little triangle, let me color it in yellow so it's more easy to see. Actually, that is not easier to see. Yellow is a bad color on top of yellow. So this little green triangle, it has two angles. It has this right angle here. Hopefully you can see with that notation or that label there. And then it's got this little angle right here. Hopefully that's big enough. Let me draw a big arrow pointing to the one I'm talking about. You kind of see that I marked it right here. And now the question is, how do you know that it's the same as another angle? Well, think about this big green triangle right here, right? Part of it, one of the vertices, is this angle again. So just follow the black arrow, and you kind of see that that big triangle has that exact same angle. So this is going to help us, because now we know, now we have kind of some proportions that we can set up because we know these two are similar. So what you should remember from proportional figures and polygons, and especially triangles in this case, is they have the same proportion. What that means is if one side of a triangle, of a bigger triangle, is double the size of the other triangle, then every single side is double the size. So we can use that, and we can say that we can pick whatever we want, really, but what we kind of need here is this height right here. So that's what I'm going to solve for, because that's what kind of got me stuck before. So what I'm going to do is I'm going to say, okay, let me highlight in blue, 18 to this entire side, which we said was 8 plus y. So think about 18 as that side length of the little triangle, and it should be 18 plus y, not 8 plus y. And 18 plus y is that same side, corresponding side on the big triangle. So we can set up proportions, and the good thing is we talk about proportions a lot on this show. And we can say 18, so the side of the little triangle, the proportion to the big triangle, which was 18 plus y, should be the same proportion or equal to the height of the little triangle divided by the height of the big triangle, which is h. And now that I'm looking at this, we still don't have enough information, right? Because we have all these variables. So let's think about how else we can do this. And I might have to think about this for a second now. And this is what's so fun about geometry. Like I'm missing something here.
It is, it's a puzzle.
So what I'm trying to think about now is what's a way that I can relate all of these kind of pieces here. Oh, wait a minute.
Radius?
You know what? I'm overthinking this. I could have done, nope. Oh, we do need the radius,
Diameter.
don't we?
Or you could do a diameter or a radius, possibly.
Diameter or radius, if we knew, well, we don't have any other
Yeah, because
information
you know
about
that's
that.
16. That little bit is 16. So you could find you could do Pythagorean to find the diameter.
Wait 1 second, 18 to 8 is 16. Oh, you know what, let me take a step back.
Yeah.
I got it, actually. I was thinking about the wrong proportions. We don't know h, so that's a problem, right? But we can find x using this. Instead of saying 18 to, we can actually say 18 to, nope, that's not going to work either. What were you saying?
You don't know y at all,
I don't know why.
and you don't know h,
Right.
and you don't know x.
I mean, I could do 18 plus y squared plus 18 plus x squared, or plus h squared, but I don't know h.
Right. Find x and y. Could you find so you know that oh no, you don't know the area of the circle.
Oh, well, we could do actually, nope, because it's that h is kind of messing us up.
Yeah. Okay.
Oh, you know what I forgot about? We know the area. Nope, that doesn't help us, right? Because we still don't know the height. I was going to say we know the area of the big triangle, but we still have that variable in the bottom.
I have to play around with it on paper.
Yeah, how about we do this? I'm going to maybe stop here for a second because I actually have to think about this. And a lot of these more challenging geometry problems, this is kind of the process. I just don't want to spend 10 minutes kind of walking
here
through my
playing,
thought
right.
process, right? So I'm going to think about this, and actually I think we're going to go on break right now. Is that right?
Mm-hmm.
And then when we come back, we're going to have a guest, and then after that, we'll come back to this problem.
Perfect.
I just probably need a couple minutes to think this through a little bit.
Yeah.